All right, since so many of you indicated that you're having some issues with number 16 in the problem set, here's an example. Basically, I'll just walk you step by step through how I would resolve this problem using Newton's second law type thinking. All right, so here we go. So number 16, a woman stands on a bathroom scale in a motionless elevator. When the elevator begins to move, the scale briefly reads only 0.75 of her regular weight. Calculate the acceleration of the elevator and find the direction of acceleration. One of the first things I do when I'm approaching any of these Newton's second law questions is I'm going to start off with something that we talked about in class the other day very briefly. I'm going to start off with an FBD, with a free body diagram. All right, remember, a free body diagram is intended to show all of the forces acting on that object. In this case, the object is the woman who is standing on that bathroom scale. What are the forces acting on her? One of them is the force of gravity acting down, obviously. All right, and at the same time, the floor of the elevator, or actually the scale, is pushing up on her with a normal force. All right. Now, one of the first things I've got to do is I've got to account for the different directions of these two forces. We could stick with standard Cartesian coordinates, up being positive, down being negative. And so what I'll do is I'll designate down as the negative direction. So the force of gravity is going to, by that standard, is going to be a negative force. All right. As far as the normal force, in this case, it tells us right there in the question how big that normal force is. It says that the scale reads only 0.75 times her regular weight. Well, since her regular weight is given by mg, where, by the way, g represents the acceleration of gravity, we can write it like that. All right? And then we are asked to find the magnitude and the direction of acceleration. So there's my givens. Believe it or not, I can use this as a way of recording my givens. And then my unknown is acceleration. All right? So that takes us to the next step of the guesswork of the guesswork protocol. So we've listed our givens, we've listed our unknown. Now it's time to write out an equation. All right? As far as the equation goes, let's remember what Newton's second law states. Newton's second law states that the net force acting on an object causes a mass to accelerate. What do we mean by net force? Net force is the sum of all forces acting on an object. So if that's the case, what are all the forces acting on that object? This is why I did the free body diagram. I revert back to my free body diagram. The two forces I've got are the normal force, and in the opposite direction, remember, net force is the sum of all forces. In the opposite direction, I've got the weight of that object. So those two forces combine to give the sum of the forces to cause that mass to accelerate. All right? So now, there's my unknown. I can isolate my unknown now by dividing out mass on both sides. And then, since that's a negative, that becomes that divided by that. And then let's remember that how big the normal force was. It's 0.75, the weight of her. And by the way, typo, time to delete there. Her weight is represented by mg, not just g, the acceleration of gravity. All right. So back over here. So now I substitute this value in for her normal force. 0.75 mg minus mg, her weight, her normal weight, divided by her mass. I see that I have three like terms, so those cancel out. So I'm left with 0.75 g minus g. So what that gives me is negative 0.25 g. All right, I could stop there, or I could go ahead. It's perfectly acceptable to stop there, or I could go ahead and substitute in our accepted value for the acceleration of gravity and stick in the sig figs. that gives me negative 2.45 meters per second squared. All right, so there's the magnitude of the acceleration. Then the question is, well, what about the direction? Well, go back to our beginning. At the very beginning, I designated down as the negative direction. Look at the value, or look at the value of my answer here. That tells me that the acceleration is in what direction? Down. All right. There are also a few questions about number 14, but honestly, if this solves your issues with number 16, then number 14 is almost an identical question. All right. Again, I encourage you to use this same approach. In fact, sometimes I will require it with any Newton's second law question. Start off with your free body diagram. Use that to help list your givens, list your unknown, and then your equation will just be your force summation. Okay? If you have any questions, get in touch with me or just ask in class, and we'll see you next time.